Hey guys, how's it going? So today we're going to be talking about permutation importance, a technique that shows us which features in our data have the biggest impact on the predictions made by our machine learning model. So without further ado, I guess let's get into it. All right, so what we're going to do is we're going to use a data set from sklearn. So sklearn learn from sklearn dot datasets import load underscore line. And now that we have the dataset, let's import a model from sklearn dot ensemble import random forest classifier. And we're going to be working with another machine learning model as well. So from sklearn dot naive underscore base import the Gaussian NB. Random forest classifier. Cannot import name classifier. I missed an I here. Okay, now that we have the data set, we have the two models. What we're gonna do is just take a look at the data. Let's see how the data looks. So data, we're gonna rename the dataset as data, and it's gonna be load underscore line. And after that, we're gonna go x comma y. I'm gonna put data as data, and for y, we're gonna put y as target. And let's see, function object is not subscribable. Yep, that should do it. Let's take a look at our data. So X, these are the features in the data set, and Y, this is the classifier or classification. So we have three different, it's 0, 1, or 2 classification, and these are the features. So now what we're gonna do is we're gonna train a machine learning model on this data set. So starting from random forest. All right, so we're gonna split the data into test and train sets. So let's go from sklearn dot model underscore selection import test right train underscore test underscore split. So now we're gonna go x underscore train comma x underscore test comma y underscore train comma y underscore test equals to train underscore test underscore split x comma y comma test underscore size equals to 0.2. So what it does is test size is 0.2 and train size would be 0.8. So 80% of the data is going to be used for training, and 20% of the data is going to be used for testing. So after we do that, all right, we're going to do CLF. That's going to be our model name, okay? CLF equals to random forest classifier. Is it 2 classifier? N underscore jobs equals to -1. N underscore jobs equals to -1 does nothing actually. It just it tells the computer to use all the CPU cores. That's what it does. All right, so our model is trained. Now what we're gonna do is clf dot score. Let's check. Missing the arguments. Oh, never mind. CLF dot fit. We haven't. That's just the variable just has the model in it. We haven't trained the model yet, so we're gonna do fit underscore x underscore train comma y underscore train. Name CLF is not defined. For some reason my C is capital here. All right, it's done. So now we're gonna do CLF dot score. Yes, of course. Or x underscore test. I don't know why. I usually have like smaller variables, so I don't really forget it, but it's not working. Test y test x test. Let's see. So our model has an accuracy of 97%, which is really good. So now we're gonna see which features are more important than others, or like which features influence the outcome more, which features are really the driving force for the model. All right. Same thing said 3 different times, but whatever. So it is CLF dot importance. It's an inbuilt feature importance mechanism. It's not every machine learning model has this, just so you know. So we're gonna go, sorry, it's feature underscore importances underscore. Yes. So these are the feature importances score, and what we're gonna do is we're gonna put it in a variable called IMP, and we're gonna make a dictionary of the feature names. So it's feature underscore names comma feature score. So now it'll be a little more easier to understand because we don't know what these numbers mean. Like, they're not associated with anything. So now we'll be able to see what they're associated with and which features are actually behind the, you know, predictions of this model. At most argument 1, what I'm gonna do is I'm gonna just zip these two together, and that should give us MP. All right, now you can see, so alcohol is one of the features, malic acid is one of the features, ash is one of the features, and so on and so forth. So this is not sorted. So if we sort it in descending order, so highest being the first, then lower, lower, we can tell which features influence the prediction of the model the most. So which features are more important and which features are less important. So what we're gonna do is I'm gonna sort it. So how you sort a dictionary is, let's see if I remember it. I know it by heart, just so you know, because I've done it so many times, but should be pretty easy. I think it's KV for K. So K is the key, V is the, so K is features, V is feature importance. So K is this, V is this. We're gonna do V in sorted. All right, so sorted, what are we sorting? Imp dot items comma key equals to lambda x given x of 1 and reverse equals to true. Items, think. Alright, so as we can see, color intensity is the most important variable, most important feature in the model. Right next to it is flavonoids, proline, and so on and so forth. So you can see which features are actually more important for the model to classify accurately. So now that we have this, what we're gonna do is, so this is for random forest. Now what we're gonna do is we're gonna do the same thing, but we are gonna, let me just give it some space. We're gonna train another model on Gaussian naive bears. So let's do this. We're gonna do CLF1 equals to Gaussian bear and n underscore jobs equals to -1, and an expected argument. We don't have to do that. Probably I don't use that. When you, all right, I'm not gonna type it out again. I'm gonna put 1. We're gonna use the same train set, same test set. All right, so we have a similar, oh my god. All right, we have 91% accuracy for naive bears, which is not bad. I mean, it's worse than this, but still, it's not real bad. And now, what I want to show you guys is this function right here, the feature importance. The one, this is the model with the naive bears, so we do not have it. A Gaussian NB object has no attribute called feature importance. So for this particular machine learning model, we do not have a feature importance mechanism built in. So this is where permutation importance comes in. So how feature importance works is it's gonna take one of the features and it's gonna randomize the values, and then it's gonna run it through the model again, and then it's gonna check the score and see the variance in the score compared to before. So I don't know, so I'm gonna pop a little window here so you can see all the features. So we have color intensity, we have flavonoids, we have proline. So just think of it, and it's a iterative process, so it goes on for multiple loops. And it's gonna go, like, let's say for the first loop it went with proline, it's gonna randomize the values in proline, and then it's gonna run the data through the model, and then it's gonna, when we look for the accuracy, if the accuracy has changed dramatically, then we can conclude that proline is an important feature. If it did not change, let's see, if we messed up the values of proline in the data set and the accuracy of the model did not change, what does that tell you? That the model does not care, or like has less use for proline. And so you can tell, like, the model just performed fine with proline's values being like randomized, you know. So it means the model does not care about proline. So model, that feature is not as important as, let's say, color intensity. Let's say if we randomize the values of the color intensity and then we check for the accuracy of the model, and the accuracy of the model just went down drastically. Okay, it changed dramatically. What does that tell you? That tells you that this feature is kind of driving the accuracy of the model. So this feature is important for. You see how it does it? So that's how permutation importance works. So let's see the code for it. All right. So what we're gonna do is we're gonna go from sklearn dot inspection import permutation underscore importance. All right, we got that. Now what we're gonna do is imp1 equals to, let's see if we've used, nope, well, we just use them. So imp1 equals to permutation importance. I'm gonna type it out. Permutation importance. So we're gonna put CLF1, the model, and we're gonna put a test score. Yes, right here. We're gonna put X test, Y test, and we're gonna do n underscore repeats equals to let's put like 50. So it's gonna repeat 50 times and give it some space so it looks good, even though I don't usually do that. All right, and now one. All right, so here it is. All we're gonna care about is importance means. So all we care about is still here. We don't care about the standard. We don't care about the array. We just want the mean. Oh, so what we're gonna do is, let's see if I have, okay. So I'm gonna do this. I'm gonna copy this. I've already written the code for it, so I'm just copy pasting it. And I'm gonna go 1. I'm gonna go feature names the same, and here I'm gonna go imp1 dot importance is mean. So that should give me, just so you know, I keep overriding the same variable. It's not a good practice to do that, apparently. Oh, well, that's what my professor said. So you can see we got a feature importance score for a naive spares. It's not inbuilt, so we had to import another library, not a library, but we had to import permutation importance to do this. So we got something. Now what we're gonna do is, oh, we have to like, wait, where did it go? We have to sort it again. Oh, I can probably copy this. Okay, yeah, it's right here. We'll see. All right, now we're gonna go imp1 items. Imp1. All right, that should be good. All right, so as you can see here, it says flavonoids is the top with 0.3, proline, alcohol, and what was, so this is for naive spares, imp1, and this is for random forest. Flavonoids is still on top. Proline is second here. You can see proline right here. Alcohol's a little further down. It's not really. Alcohol is third here. It's fifth here. And yeah, it's not going to be exactly the same because they're two different models. The two different models, but I can still train. I can use permutation importance. Wait, I can use permutation importance on this. So I'm gonna go imp random forest. So I'm gonna use permutation importance right here on random forest. So I'm gonna go CLF, repeat 1, and I'm gonna press enter. I want to print it out. It's gonna take a time. It's gonna take a while because random forest is a little more CPU intensive. I should have put in, you know, for random forest, it's good to put in n underscore jobs as -1, so it uses all the cores and makes it easier. I gotta put it into a dictionary. RF. And now we're gonna sort it. RF. All right, and we're just gonna call IMP just to see. Okay, so this is the feature importance according to permutation importance, and this is just feature. It's the inbuilt mechanism. It's feature importance. So let's see. We still have flavonoids on top. It's close right here. And proline is second. Apparently color intensity is fourth. It was given for, it's not going to be exactly the same, but it's a really useful technique to know to explain models that do not have inbuilt feature importance, you know? So like for naive bears, we could use this to explain the model a little more, like which features are affecting the outcome more, so you can explain it to, you can just explain the model a little better, you know, instead of being like, oh, I got this outcome, I don't know how. So you have a little more explainability using these techniques. And yeah, so you can use it on naive bears, you can use it for SVM, you can also use it for KNN. So yep, thank you for watching, and I'll see you guys in the next one.